Hello and welcome to this video about solving one-step equations. This one is simply about examples, or this video that is just about examples. I have another video explaining the mechanics and sort of the ideas behind solving one-step equations that you can watch if you're interested in that. But here I just want to walk through some examples. So the first thing I want to talk about is the process. When it comes to solving equations, there are a couple main ideas that we have to keep in mind. The first one are two really important words: isolate and balance. So the idea behind isolating and balancing is that we want to isolate the variable and balance the equation. And in order to isolate and balance, you have to use inverse operations. And inverse operations are opposite operations. So let's write that word right there. Opposite operations. So if something's being added to x, you got to subtract it. If something's being divided into x, you have to multiply by it. And so you're just going to use inverse operations. And then another little tip here, and this is especially for those students who struggle a little bit with math and math doesn't come naturally to. I'm going to say use a mirror line. Now, this isn't really a formal, mathematical tool or device, but it is a tip that helps out a lot of students when it comes to this idea of how do you balance things out. So now, with that being said, let's do some examples. So let's say we have the equation x minus 7 is equal to 9. So the first step is to isolate and balance. We want to get x all by itself. And so we got to ask ourselves, what's happening to x? Right now, we're subtracting 7 from x. So we want to use the inverse, which would be adding 7. Now here is where we use a mirror line. And so the mirror line, the idea is whatever happens on the left-hand side of it also has to happen on the right-hand side. And so here we have to add 7 to both sides. And so we end up getting nothing on the left-hand side except x. We have now completely isolated the variable. And we have 16 on the other side. And so there's our final answer, 16. Now let's do a slightly more difficult example. Let's say we have, let's go with 3x is equal to 21. So again, we want to isolate the variable. We want to get x all by itself. So we have to ask what's happening next to x. And what we have going on here is 3 times x. So there's a little multiplication sign that's implied there, even though you don't see it. So since we're timesing by 3, we need to divide by 3. And then we have to use the mirror line. Whatever happens on one side of it has to happen on the other side. So we divide by 3 as well on the right-hand side. Now we simplify. 3 and 3 cancel out, leaving us with just x on the left-hand side, which is what we want. And then we go 21 divided by 3, that's 7. And our final answer here is 7. One final example for you, and this is about as tricky as one-step equations can get, is that if you do something like 4/5 x is equal to 20. Now what's tricky about this is that we have a fraction right here. And that's what's throwing everything off. And I mean, it doesn't throw a lot of stuff off, but it's a different look. And again, if you're a student who struggles with math, this is just an added barrier to you succeeding with this problem. So we'll ask ourselves, what's happening to x? It's being multiplied by 4/5. So what we need to do is divide by 4/5. And using our mirror line, we have to do it on both sides. Divide both sides by 4/5. Now, dividing fractions, you have to flip this number, or you have to flip 4/5 and multiply by the reciprocal. So instead of dividing by 4/5, we're actually going to multiply by 5/4. And we'll do that on both sides. And so again, that's what makes this tricky, is that extra step. And if you're not good with fraction arithmetic, then this is definitely a barrier for you. But I'll show you another example, or another way to get through this problem if you really struggle with fractions. But now, 5s cancel out, the 4s cancel out, everything else has been canceled out on this side of the equation except for x. And then on the right-hand side, we can reduce this number. This is 20 over 1. 20 and 4 reduce to get 5, and then we have a 1 there, so 5 times 5 is 25. And that's our final answer for this. Now, I'd tell you another way to do this. So let's talk about another way to solve a problem like this. So maybe you're not the best with fraction arithmetic. That's totally fine. You can think of this as, I'm going to rewrite it, 4x divided by 5 is equal to 20. So what I can do is focus on the 5 first. It's in the denominator, meaning I'm dividing by 5. So what I will do is I will times both sides by 5. So now I'm getting rid of the 5 here, and I have 4x is equal to 100. And then I will divide by 4, get rid of the 4's, and x equals 25. So if you want to, you can deal with fractions in 2 steps. If you're good with fraction arithmetic, you can do it in 1 step. But if you struggle with it, this is another option for you. So those are some examples. Just to kind of recap everything, it all boils down to these 3 things. Isolate and balance, use inverse, aka opposite operations, and then use a mirror line to help organize everything. Because this lays the foundation for how to solve multi-step equations that are just linear, and then when you go to more advanced math, radical equations, quadratic equations, the method and the process is very similar and relies on all these principles. So if you can do these, you're setting yourself up for success later down the road.